In this section, we're going to talk about how we can interpret data that's presented in tables. So the first kind of a table we're going to look at is called a two-way frequency table. So a two-way frequency table. It's used to show the frequencies of data from a survey or experiment classified according to two categories. So it's called two-way because it's looking at two categories. And rows indicate one of the categories. Rows are the horizontal. And columns indicate the other. That's the vertical. So this is a two-way table. It talks about student-centered preferences. And the two variables it's considering are whether the students are freshmen, ninth graders, or sophomores, 10th graders, and if they prefer to have video games, board games, or table sports in the student center. So organizers at Lincoln High School are planning a new student center. They surveyed freshmen and sophomores about what type of games they would like to have: video games, board games, or table sports. Students are asked to select only one type of game. The results are shown in the table. Now, the reason they call it a frequency table, sometimes tables show percentages, but this one is not. It's showing the actual number of people who chose each one. So we know that 20 freshmen picked video games, 55 freshmen picked board games, and so on. And there were a total of 105 freshmen they talked to, a total of 395 sophomores they talked to, 500 students in total. You can just add these two together, 105 plus 395, to get the 500. So of the students who chose table sports, how many of them were freshmen? So this is saying, let's look just at this row of table sports. So of the students who chose table sports, so we're limiting ourselves to just this row, how many of them are freshmen? So where table sports and freshmen overlap, it's the number 30. This says how many students chose video games. So this doesn't limit us to looking at just freshmen or just sophomores. It just says how many students in total chose video games. So we look at the video game row. This does show us individual class choices here and here, but the total is what we want. So in total, 190 students picked video games. How many students are freshmen? So this time we look at the column, freshmen. We see how many chose each one, but the total is what we're interested in. A total of 105 freshmen were interviewed. And then how many students were surveyed in total? So that's right here. It's 500. And you can get the 500 either by adding these two numbers together or by adding these three together. Both this row adds up to 500, and this column adds up to 500. Now, one teacher suggested that the budget for the student center should be split evenly between freshmen and sophomores. Another teacher disagrees. So what argument could be made in either direction? Okay, so let's look. Let's assume this is a pretty good reflection of their student body. So about 105 freshmen were talked to, and 395 sophomores were talked to. So think for a second, would it make sense to just split it evenly and put half the money towards the freshmen, half the money towards the sophomores? It doesn't seem like a 50-50 split would be fair because there's a lot fewer freshmen than there are sophomores. Who knows why this school is so imbalanced here, but they've got 100, basically, let's just make it easier numbers. They've got 100 freshmen and almost 400 sophomores. So 100 out of 500, you can do this in your calculator. Just type in 100 divided by 500, you get 0.2. So you could say the table shows about 20% of the students are freshmen. And about 80% are sophomores. So a 20-80 split seems more fair. This table shows craft options chosen by freshmen and sophomores at a camp event. So 3 crafts that they can choose from: sand art, a keychain, and a picture frame. And you can see the choices here made by the freshmen and the sophomores. So our first question is, which craft was most popular overall? So since we're looking for overall, we want to look over here at the total column. Now we look at this total column instead of this one because we're not concerned with how many freshmen there are in total or sophomores at the moment. We're concerned with the overall or total votes for each craft. So since we're looking at overall, we can ignore these and just look only at this column. So as we look at this column, we see that one of the highest votes was right here. Sand art got 37 votes. So overall, the most popular was sand art. Next, it says which craft was most popular with sophomores. So we're limiting our view now to just see what the sophomores said. So as we look just at that column, we can see it's not sand art on top, but the keychain won by a little bit. The keychain was most popular among sophomores. Then C says how many freshmen attended the camp event. So looking for the total number of freshmen. So we look at the column that says freshmen, and the total is 47. How many attendees did crafts overall? So we're looking for the total number of attendees. We know there's 47 freshmen, 41 sophomores, for a total of 88. So the total number doing it was 88. Number 3, a small town conducted a survey to help decide on which community initiatives they should spend annual funding. The town has 24 residents who responded to the survey. So already down here, they've got 2,400 down as the total number of people who are in the survey, who responded to the survey. Okay, according to the survey, 45% of residents are cyclists. Okay, so 45 are cyclists. Let me grab my calculator. I forgot to bring it over. Stand by. Okay. So that means the total number of cyclists is 45% of 2,400. So to get that, I can just type in 0.45 times 2,400. So the total number of cyclists is 1080. Now, you have to look at the wording carefully. 45% of the respondents are cyclists, of whom, so that means we're looking just at the cyclists for now. So this next piece of info, we are only considering this row that's about cyclists, of whom 80% enjoy spending time at the lake. So 80% of the cyclists enjoy spending time at the lake. So we'll do 80% of 1080, 0.80 for 80%, times 1080. So 864 enjoy spending time at the lake. Now, sorry, I want to pause right here because there's some blanks we can fill in based on the info we have. We know 45% are cyclists, meaning 1,080 of this group are cyclists. We can fill in this blank because we know 1080 plus this should equal 2,400. So if I do 2,400 minus 1080, that tells me there are 1,320 who are not cyclists. Also, in a similar way, we can look at the cyclist row. We know there's a total number of 1,080 cyclists. 864 enjoy the lake. We can figure out how many didn't enjoy the lake because we know 864 plus this number is 1080. So if we do 1080 minus 864, 216 cyclists do not enjoy spending time at the lake. So even though they only gave us 2 pieces of info, we were able to use that to get 2 more pieces of info. So now let's look at the next sentence. Of the residents who are not cyclists. So we are looking just at this row right now, the non-cyclists. 75% enjoy spending time at the lake. So this is why I went ahead and filled in this blank, because we need to know the total number of cyclists if we're going to figure out what 75% of them is. So 75% of 1320, 0.75 times 1320, we get 990. So 75% or 990 enjoy spending time at the lake. So if you see, there's actually a lot, believe it or not, we now have enough info, we can fill in everything. We can find the total number that enjoy the lake by adding 864 plus 990, giving us 1854. I can figure out how many non-cyclists don't enjoy the lake by doing 1320 minus 990. Hit 330. So we can fill in the rest of it by finding the total number who don't enjoy the lake by adding these two together, making it 546. And we can confirm that 546 is correct if we want to, because we know these two, 1854 and 546, should add up to 2400. So we can confirm we were doing the right thing. Sorry about that. We add those two numbers together. 1854 plus 546. Boom, it is 2400. So it's pretty cool that the way these tables work, they gave us, I think there's 9 blocks here, 3 by 3 in this case. They gave us the total number of people. Then they told us 1, 2, 3 blocks, or I think it was this block. Anyway, with less than half the blocks, we were able to fill in all of it by using what we knew about the totals for each row in each column. A two-way table displays the numbers, the values of people or objects in each category and subcategory. A two-way relative frequency table displays the ratios or the percents for each category and subcategory. So to create these, we'll have to divide each total by the total number of observations in that category. So we'll see this in number 4. So when the word relative is not there, when it just says frequency table, that's like what this one does. It shows you the count for each group. But a relative frequency table, which we're going to create down here, shows the percents in each group. Okay, so make a relative frequency table by converting the data into percentages. So we know that all of these numbers are out of 200. So to find what these all are in terms of percents, we just need to take that value and divide it by 200. So it takes a little bit of time, but it's not difficult. We just do 86 divided by 200. That gives us 0.43, which we convert to 43%. We do 24 divided by 200, which is 0.12. That would change to 12%. 16 divided by 200 is 0.08, which we convert to 8%. Now, to get the total, you can just add these three together. 43 plus 12 is 55, plus 8 is 63. But you could also do 126 divided by 200. That gives you 0.63, which is 63%. Oh, and we know this one down here is going to be 100% because this is where the total is shown. So that's got to be 100%. So just like we were filling in gaps on the previous question, we could do that here. If the total is 100% and this is 63%, we could do 100 minus 63 to figure out that this has to be 37%. So to get this row, 2 divided by 200 is 0.01, so that's 1%. 40 divided by 200 is 0.20, so that's 20%. And 32 divided by 200 is 0.16, or 16%. And a confirmation that we did this correctly, 1 plus 20 is 21. 21 plus 16 is 37. %, plus 1% is 44%. 12 plus 20 is 32%. And 8 plus 16 is 24%. And you could just as easily have said 88 divided by 200 is 0.44, 44%. So you can do this by dividing just like we do the others, but you can also fill in gaps the way we did on the previous question. Okay, so now we have a frequency table. So we're going to ignore this table up top and just answer the next questions using this version of the table. So it says find the joint frequency of rock climbing and bringing guests. Joint means both are true. So we're looking for rock climbing, so I look just at this row for rock climbing, and ones who did bring guests, which is this column. So we have an overlap between rock climbing and bringing guests right here at the 43% mark. So what that means is 43% of the guests, 43% of the people who attended the gym were rock climbers who brought guests. C, find the joint frequency of weightlifting and not bringing guests. So weightlifting is this row, not bringing guests is this column. So where the overlap is right here at the 20%. So 20% of the gym members come for weightlifting and do not bring guests. Okay, the dance squad is planning to buy new uniforms. The coach asked members of the varsity and junior varsity squads which color of the uniform they'd prefer. The results are recorded in this relative frequency table. What percentage of members who prefer blue uniforms are on the varsity squad? Okay, so what percent of members who prefer blue? So right now, for A, we're going to focus just on the row that says blue uniforms. So what percentage of those who prefer blue uniforms, looking just at this row, are on the varsity squad? So since we are limiting our vision to only look at the row, I can't do this easily, at the blue, we only look at the numbers on this row as well. So the varsity is 19%, and we divide that by the total in the blue category, which is 30. So we get 19 over 30, which if you type that in your calculator, you'll see you get 0.633 repeating. So we change that to a percent, so it would be 63.3%. So I want to pause and make sure I'm explaining this part well, because this is, you don't have to remember the word, this is more called conditional probability, because it's narrowing it down. It's saying if we look only at the people who prefer blue uniforms. So if we narrow our focus to just this one line, people who prefer blue uniforms, we know 19 out of 30 of them are on the varsity team. So we can figure out the percent by doing 19 over 30. I meant to put 1 percentage point, hold on. There we go. So we are looking only at one row for that question. Now for part B, what percent of the JV squad prefers red uniforms? So this time we're focused only on this column. because they're saying what percent of junior varsity. We only look at the junior varsity row. Prefer red. So I see junior varsity red, that's 28%. And we divide that by the total number who in JV, which is 61. So we do 28 over 61, which is about 45.9%. What percent of members who prefer black uniforms? So for C, we're focused just on this row. What they list first is where you are narrowed down to. So if we look back at A, it said, what percent of members who prefer blue uniforms? So I said, we will look only at the blue uniform row. B says, what percentage of JV squad? So I looked only at the junior varsity column. C says, what percent of members who prefer black? So we use only this row into this question, or on the JV squad. So we look at the black row. Junior varsity is 22 out of 38. So we do 22 divided by 38, and that comes out to about 57.9%. D, what percent of the varsity squad prefers blue uniforms? What they say first is what we narrow down to. What percent of the varsity? So I look only at this column. What percent of the varsity prefers blue uniforms? So looking at just this column, there's 19 in the blue section out of a total of 39. So I say 19 over 39, which is approximately 48.7%. Just a word, this last thing is just to help you with a word. The subtotal of each subcategory are called marginal categories or marginal totals as well. So this is the total. These are the marginal totals because they're just telling us the total in one variable and one value. So this is only the total who brought guests. This is only the total who did not bring guests. This is just the total of weightlifters, just the total of cooking class, and so on. Those are called marginal. So if you hear the word marginal, just want to make sure you know it's talking about a single row or single column that's not a total.